Hello, everybody. Something very special was released today. And no, I'm not talking about the newest episode of The Mandalorian. Even better, 7-1, adding and subtracting polynomials on the Mathnasium. In today's video, I'm going to first tell you some vocabulary for a polynomial and what a polynomial is. And then you're going to learn how to add and subtract them. It turns out I think everyone's going to be very successful at this because it's very similar to something that we've already done. It's very similar to combining like terms. So without further ado, let's get started. We got my boy Gandalf here with us today. We're going to go ahead and jump right in with a lot of vocabulary. Hope you got a sharpened pencil. Okay, first vocabulary word. What is monomial? What is a monomial? It is an expression that is a number, a variable, or a product of a number and one or more variables. Basically, in this class, it looks like a number, a variable, or a product of numbers and variables. What did I call this in the past? Well, in the past, instead of saying monomial, I would just say term. Okay, now term is not all terms are monomials, but all monomials are terms. When I said combining like terms, I'm really talking about these things that we kind of add or subtract together. So let's go through. I'm going to kind of color code these. Number, if it's just a number like this, we call that a monomial. A variable, that's like this. Or a product, numbers and variables. And that would be like this one, which is negative 5 times x times x. Right? We have two x's and a negative 5, so that's a product. How about over here? What about c divided by 4? Is this a product? Doesn't look like a product. Looks like division to me, Mr. Slagle. Going crazy here. So how do we... is it possible to write this as a product? Turns out, yes, it is. We're just going to use that rule for dividing fractions. Whenever you divide by a fraction, we'll be dividing by 4 over 1. It's the same as multiplying by that fraction's reciprocal. So we would do c over 1 times 1 over 4. Hey, you know what? That looks like a number, a product between numbers and variables to me, because I can write that as 1/4 c. Perfect. So all of these things are terms in a polynomial. And basically how you make a polynomial is you take a bunch of monomials and you glue them together, or you add them or subtract them in different combinations. And what that does on a graph is it creates this, a lot of times, sometimes it's a line, sometimes it's a curve, sometimes it's this really crazy squiggly looking thing. We're not going to be graphing a crazy amount of these, but it's helpful to know that this is linked to a graph, and polynomials have their own set of graphing rules that you'll learn later down the road. So our first vocabulary word, monomial. These are all examples of monomials. So what isn't a monomial? You could have a term that's not a monomial and it might look something like this. So something that is a monomial cannot have a fractional exponent. It cannot have a variable in the denominator. So like if you had an expression that said 6x squared plus 5 over x, that's no bueno. This is not a polynomial because you have a variable in the denominator. It can also, in order for it to be a polynomial, should not have 2 to the x. And it turns out there are a bunch of things that it can't have. So just rather than focus on what it isn't, focus on what it is: a number, variable, and a product of numbers or variables. Okay, every monomial has what's called a degree. To find the degree on paper or using algebra, you just take all of the variables. Sometimes it's just one, but you take the variables and you add up all their exponents. That will tell you the degree of the monomial. And the degree is very important because it turns out there's a relationship between the degree of a monomial and that monomial's shape when you graph it. I say like you plug something in. So let's go ahead and take a look at these examples, and we're going to talk about the degree of each of these. All right, let's do this. Okay, Okay, following that definition, the degree of this, it's a product of a number and a variable. It's the sum of the exponents of the variables. Well, the exponent here is just 1, so this has degree 1. There's only one variable, so you just take that number. There's only one variable here, so this has degree 2. Uh-oh, we have two variables, so what do? We're going to add up their exponents. This is degree 5. And here, there are no variables at all, right? So how could they have an exponent? Well, you could write it like 3 times x to the 0, because x to the 0 is 1. So we say that this is degree 0. That is how you identify the degree of a monomial. So the degree of a non-zero constant is 0, and 0 is said to have no degree. So what's a polynomial? Like I said before, polynomials, we take a bunch of monomials and you glue them together. Polynomial is a monomial, or a sum or difference of 2 or more monomials. Okay, so great. I'm going to maybe draw a little picture here that might help. So let's say this circle represents the collection of all polynomials. Okay, there are polynomials that have one term. We call those a monomial. That is also a polynomial. There are polynomials that have 2 terms. That's called a binomial. Okay, as in right here, binomial, like bicycle, 2 terms. Yeah, so that's also a polynomial, and a polynomial with 3 terms is called a trinomial. Okay, so monomial, binomial, trinomial, that prefix just tell you how many terms, and anything really that has more than that amount of terms, we just say polynomial because there isn't a phrase for those. So let's take a look at some examples. We're going to look at this one. Yeah, let's do this. Let me change colors. All right. So we're going to first, whenever you name a polynomial, you first name it by degree and then number of terms. So to find the degree, the degree of a polynomial is the highest degree of its terms. So this actually gets a little more complicated, so we'll hold off on that. Let's just do the second word in the naming process, which is based off of number of terms. So this is 1, 2, 3 terms. So this is a trinomial. Hey, cool. This is 1, 2 terms. So this is a binomial. Also cool. And this one is 1, 2, 3, 4 terms. There's no word for 4, so we just use the general term, which is polynomial. So this is a trinomial. There's 1, 2, 3, binomial 2, and 4. Anything 4 or more, we just say polynomial. So how do you find the degree? Well, it turns out there's a different name. Well, finding degree is just the highest degree of its terms, but it turns out there's a different naming scheme for different degrees. So to find this, so let's find the degree of this first one. So the degree of the first term is 4. The degree of the second term is 2. The degree of the third term is 0. So what's the degree of this polynomial? It is the highest one. The reason it's the highest one is because the highest one is what determines the overall kind of shape of that polynomial. So that's the one that kind of we say is the most important. And it has to do with when you plug in, really big numbers, this one kind of wins out. Anyways, let's go over the names for these so we can kind of have an idea. Degree 1 polynomials would be like something that looks like y equals 3x plus 2. Hey, that looks like slope-intercept form. Slope-intercept form was the form of a line, so degree 1 is linear. Degree 2 is a little counterintuitive. Just keep it on green. Degree 2 is called quadratic. We'll be graphing these later. Quadratic. Okay. Degree 3, if a block in 3 dimensions, is called a cube. So this is cubic, just to help myself remember. 3 cube, like 3 dimensions. Degree 4, there are 4 what's in a gallon, 4 quarts, so quartic is the word we use for that. Degree 5 is called quintic, but you don't need to worry about that for this class. Degree 0 is just a constant. And degree 9, anything basically bigger than degree 4 for this class, you just say it's degree, and then it's just degree 9. So basically, you don't have a special name. The only ones that have special names are these ones. You can just say the number in other scenarios. Okay, so let's go through and name each of these polynomials by their degree. So the highest degree is degree 4, degree 2, degree 0. The highest degree is 4, so this is a quartic trinomial. Here, this one is degree 1 and degree 1. The highest number is 1, so this is a linear binomial. And then over here, this is degree 5, degree 3, degree 1, and degree 0. The highest is 5, so we will just call this a degree 5 polynomial. Super. All right. Let's keep cruising here. See some examples. All right, so you can practice naming these on your own. I'm going to go through and label them momentarily. Starting at the top, 4x plus 7, there are two terms, so it's a binomial, and this has degree 1, this has degree 0, the highest is 1, so this is a linear binomial. Okay, this is degree 2, degree 1, degree 0, the highest is 2. So we look at that phrase for degree 2, which is quadratic trinomial. And they should be in this order. It's always degree and then number of terms. And then here, it's just a number, so it's a constant, so this has degree 0, which means this is a constant. Sometimes usually we just say constant, but if we're following the naming trend, it's a constant monomial. Okay, so the reason we went over those terms is that's just how you name and identify those things. Hopefully you could see all of the work that we just did. Yeah, I think so. Perfect. Okay, great. Let's keep going. All right, so how do we combine like terms when things have different powers? Turns out it's really easy. You just look for the ones that are the same variable and the same power. They have the same variables and the same powers. We can add them together. They must have the same variables, and those variables have the same power. So it says same combination of variables, but it's the same thing. So these two terms are 1x and 3x. They have the same variable, it's x to the first, so we can add them together. They are like terms. You add them together and you get 4x. Right here, they have the same variable, but those variables don't have the same power. Okay, so they have the same variables, but those variables don't have the same power. So I actually cannot combine these. I can't combine these. This is simplified. There's nothing I can do there. Can't add or subtract or whatever's going on. Okay, how about down here? 8xy squared minus 15y squared x. They have the same variables, x and y, and those variables have the same power. It's the same combination of variables, right? This is 8xy, and this is minus 15 yx. So it doesn't matter that they're out of order because we can multiply in any order. So what I'm able to do is I am able to subtract the coefficients here. 8 minus 15 gives me negative 7. And since it's written two different ways, the way that is technically correct is the one that's alphabetical. So x first and then y. So xy squared, negative 7xy squared is how we would simplify this. All right, let's take a look at this last one. Combining like terms. Typically, we start with the highest degree. So if you go through, in this case, this is degree 1, this is two variables, so this actually has degree 2, degree 0, degree 1, degree 1, degree 0. So I'm going to start here and we'll write xy. I can't combine that with any of the other x terms because there's no other term that has an x and a y, so that is all by itself. Okay, next I'm going to come down Let's do degree 1, and we'll do the ones in degree 1 in alphabetical order, okay? 8x is in degree 1, 3y is degree 1, negative 4x is degree 1, 7y is degree 1. So let's do them in alphabetical order, which would mean x is first. 8x minus 4x gives me plus 4x. Switch colors for the next one. And then 3y and 7y minus 3y plus 7y gives me also plus 4, but y this time. And then lastly, we have two constants that are both degree 0, and they will come at the end. So degree 2, degree 1, degree 1, degree 0 will be minus 6. So that's how you combine like terms. Like terms and polynomials are the ones that have the same variables, and those variables are to the same power. And that's all adding and subtracting polynomials is all you have to do is basically just combine like terms. So if it's addition, you can basically just ignore parentheses and combine like terms. Ignore parentheses and combine like terms. So let's go through and find our like terms. Firstly, in this problem, we'll start with the highest degree terms that are present. So this is degree 2, degree 0, degree 2, degree 0. So we'll do the degree 2 ones first. 3x squared plus 6x squared gives us 9x squared. Now we go down the line, degree 2, degree 1. Is there any degree 1? Nope. The next one is degree 0. So that is 8 and 6, the constants. And then 8 plus negative 6. 8 plus negative 6 is positive 2. We're done. Sounds good. All terms have been accounted for. And it is in standard form because the degree is descending, meaning it goes from the highest degree to the lowest degree. All right, let's do this again with this next problem. Okay, going through, starting with, this is degree 3, degree 1, degree 0, degree 2, degree 1, degree 0. The highest one that we saw was 3, so that's where we will start. So this will be equal to, well, is there any other degree 3 terms or that are k squareds? Nope. So this is k cubed. 4k cubed is the only degree 3 term. Let's go down to degree 2. There's only one term, that's right here. So that's just going to come along for the ride. Joyriding. Okay, and then degree 1. This is degree 1. This is degree 1, so we can add their coefficients. 5 plus 2 is plus 7. Okay, and then lastly is degree 0, which is the negative 6 and the negative 2, which will be minus 8. So that's how you add two polynomials. Go ahead and give this one a shot on your own, and we'll go over it momentarily. Okay, hope you've had a chance to try it. Feel free to pause the video if you haven't. I'm going to go through highest degree. Degree 1, degree 2, degree 0. Degree 0, degree 2, degree 1, degree 3. Remember that degree is coming from the sum of the exponents in that term. Well, there's only basically just the x in all of them, so you just take the exponent that it has. So degree 3 is the highest. There's only one degree 3 term, so that's going to come down. It'll be 3x cubed. In red, degree 2. There are two degree 2 terms, so we'll be able to add those. Negative 7x squared and minus x squared will give me minus 8x squared. Okay, degree 1 coming through is 4x is degree 1 and 14x is degree 1, so that will be plus 18x. And then lastly, we have our two constants, 8 minus 10 plus negative 10. 8 plus negative 10 will be negative 2. So that easy, folks. That's a great and easy way to add polynomials. So how do we subtract? Well, subtraction is very similar, except you add one very key step. And that key step is to, before you begin, we can't just combine like terms as it is, because this minus sign is about to change the sign of all of these. So what we do, minus negative x cubed plus y squared plus y minus x. What we have to do is we have to kind of make sure that we are distributing. This is really like distributing a negative 1. We have to make sure that we change the sign of all of the terms in the second group. It's this minus all of these. So we have to do the opposite, or negate all of the things in the second group. So this is negative, so it'll become positive x to the third. This is positive, so it will become minus y and then minus x. And now we can do business as usual, what we've been doing to simplify by combining like terms. Start with purple. Looking for the highest degree, again, is degree 3. Okay, sorry, it sounds like my son is being tortured up there. He is having fun, I promise. Negative x to the third plus x to the third. These both have a 1. Negative 1 plus 1 is 0, so those cancel and are gone. Degree 2, there's only one degree 2 term. It is y squared, so that comes along for the ride. Degree 3, or sorry, degree 1. Going down, degree 1. Ooh, there's a lot of degree 1 terms. So we have to do them in alphabetical order, or we should. So we'll do the x's first. Negative 1x and negative 1x are going to add up to negative 2x. And then we can switch to the y's. Y plus negative y is 0, so that means we're done. It's in descending degree, and we've combined all like terms. Sounds like a torture chamber in here. Okay. All right, let's do another one. Okay, again, really straightforward. Step 1, change the sign of everything in the second group. We're subtracting this, and this, so it turns into negative x squared minus 3x plus 8. Change the sign of all those numbers. It's going to end up being, let's go in descending degree. Degree 2 is the highest, so that's going to come. Make sure you include that negative sign. Then we're going to go for degree 1. There are 2 degree 1 terms, things that have exponent power 1. That is 1 minus 3, which is negative 2x. And then degree 0, which are the constants. Negative 7 plus 8 is plus 1. All right, you try this one on your own. Give it a shot. And I'm going to go over it here momentarily. Okay, step 1. Leave the first group as the same. Doesn't change at all, but then we do have to change the sign of everything in the second group. That will be minus 3y squared. It was positive, now it's negative. Minus 2x plus 2y. Now we go through with our pen, starting with the highest degree, which is degree 2. Okay, there's degree 2, there's degree 2. Oh, careful, that's why this is an x. We're going to put them in alphabetical order. So 4x squared comes first. We'll do the y squareds next. That'll be minus 3y squared. Oh no, could we see all the problems on the last sheet? I hope so. I don't know if we could. Oh, we might have been able to. I'll take a look. If you couldn't see that problem, take a look now. Sorry for that. I don't know if that was actually the case. Okay, here we go. Next color. Degree 1. This is degree 1, degree 1, degree 1. They all have exponent 1. We're going to do them in alphabetical order, which means there's only one x term. So minus 2x. And then blue, the y's. So the only thing so far that actually had 2 like terms that we could combine are these y's. Everything else has just been a carry down. So minus 9y plus 2y is going to be minus 7y. And then lastly, we just have this lone plus 1. It's like an exclamation mark. Okay, so we only had to combine two like terms there. We have subtracted the polynomials successfully. All right. Make sure when you are writing your polynomials in any circumstance, make sure that they are in descending degree. The reason we do that as mathematicians, we kind of look to that first term to determine the shape. Simplify and make sure you simplify and combine like terms that are present to get it simplified. Okay, that's it. Thanks for watching the video, and we'll see you next time.